Morning, everybody. In this class, learn the oxyacids of sulfur. In G16 element, sulfur is first element and oxyacids of sulfur. Oxyacids of sulfur. The sulfur can show number of oxyacids depending upon their oxidation state or oxidation number. The sulfur shows number of oxyacids depending upon their oxidation state as follows. So first oxyacid of sulfur is sulfurous acid. The first oxyacid of sulfur is the sulfurous acid having formula H2SO3. Sulfurous acid having the formula H2SO3, and its structure, sulfur is center and the remaining 3 oxygen and 2 hydrogen can linked with them, that is the sulfur OH bottom, then left side OH and right side double bond O. Install all oxygen 1, 2, 3 and 2 hydrogen can link to sulfur, but remaining 2 lone pair of electrons present on its present on upper side of that sulfur. So this is the structure of sulfurous acid. Second oxyacid of sulfur, name of that is sulfur oxy acid is sulfuric acid. H2SO4 is the formula of that sulfuric acid, and structure of that sulfuric acid, central atom sulfur which is linked with OH at the bottom and OH on another side of left and O double bond, S double bond O, and remaining top S double bond O. So this is the structure of sulfuric acid. Sulfurous and sulfuric. How to differentiate sulfuric and sulfurs? Sulfurous containing H2SO3 and sulfuric containing H2SO4 means that one oxygen is more in sulfuric acid than sulfurous acid. Third structure of oxyacid of sulfur is the disulfuric acid. What? Disulfuric acid having formula H2S2O7. H2S2O7, and structure becomes 2 structures of sulfuric acid can link with each other. 2 structure of sulfuric acid can link with each other to form the disulfuric acid. So this structure and again sulfuric acid another structures can link. So it gives the S central here, another S here, then OH of this side OH can link with each other and hydrogen is evaporated to form the O single bond O. So likewise that disulfuric acid structure can be obtained. It is formed by combination of 2 sulfuric acid. So this is the disulfuric acid. Third one is the peroxymonosulfuric acid. Next oxyacid of sulfur name is that the peroxymonosulfuric acid having the formula H2SO5. H2SO5, only one sulfur that is present at the center and remaining 2 OH group on bottom, then S double bond O, S double bond O, and last one is the OOH. So this is the structure of peroxymonosulfuric acid. Then next one is the peroxydisulfuric acid. Peroxydisulfuric acid having the formula H2S2O8. H2S2O8. is the formula, and structure is likewise that sulfurs are present at the centers. Both sulfurs are linked with the oxygen atoms, and sulfurs having lone pair of electrons. Each sulfur having the lone pair of electrons on the top side, remaining 2 unpaired electrons. Last oxyacid of sulfur, that is thiosulfuric acid, having the formula H2S2O3, and its structure becomes S double bond S, and total 3 OH is present at the bottoms. So this is the structure of thiosulfuric acid. In board pattern, the question of oxyacid of sulfur can ask for the 3 marks. Then you may write all these structures of the oxyacids of sulfur, because each structure carries half mark. Total 3 marks can be obtained for all these structures with formula. Not only structures, we have to require also formula of each for 3 marks. Suppose this question can also ask for the 2 marks, then you may write any 4 structures of oxyacids, does not require the 6, can write any 4s. So this is questions for the board pattern. On oxyacids of sulfur, the questions can also ask for the CET, NEET, MCQ types. Suppose which is the formula of peroxymonosulfuric acid, then you would require only the formula of monosulfuric acid, that is H2SO5. Used to what? The formula of any oxyacids of sulfur can be asked for the 1 marks questions, that is MCQ types. So we may prepare both for board pattern as well as MCQs. So these are the oxyacids of sulfur depending upon their oxidation state or oxidation number. Then see the next concept of G16 elements. Yesterday we were discussed about the allotropy of G16 elements. Each element of G16 can form the allotropy. Oxygen shows only 2 allotropic forms, that is O2 and O3. Sulfur shows number of allotropic forms, rhombic, monoclinic, plastic, milk of sulfur, chloride sulfur. Selenium can shows 2 forms depending upon their color. Likewise, tellurium can form also forms, and last polonium can use the alpha and beta. All these are discussed. So in this class, we are going to learn the next point, that is allotropy of sulfur. Allotropy of sulfur. Both questions are different. If the allotropy of G16 is asked, then you may write total 5 elements allotropy. But question can ask for only allotropy of sulfur, then you may write allotropy of sulfur only. So how to write this question? Allotropy of sulfur. First is the sulfur shows number of allotropic forms. Sulfur shows number of allotropic forms, but some important allotropous of sulfur are as follows. Sulfur gives number of allotropic forms, but in which some important forms are as follows. First one is the rhombic sulfur. And second one is the monoclinic sulfur. Monoclinic Sulfur. What is rhombic sulfur? It is also called as alpha sulfur. Rhombic sulfur is also called as alpha sulfur. The rhombic sulfur has pale yellow in color. It has pale yellow in color. The rhombic sulfur has pale yellow in color and orthorhombic crystal shape. What? Rhombic sulfur is also called as alpha sulfur. It has pale yellow in color. Then it possesses orthorhombic crystal shape. It has melting point. The rhombic sulfur has melting point 385.8 Kelvin. Means what? At 385.8 Kelvin temperature, it becomes melted, and density of rhombic sulfur is 2.06 grams per centimeter cube. Then it is insoluble in water. Rhombic sulfur cannot soluble in water because it is the organic substance, but soluble in carbon disulfide, that is CS2, organic solvent, carbon disulfide. It is stable. The rhombic sulfur is stable below rhombic sulfur is stable below 369 Kelvin temperature. Rhombic sulfur becomes stable at 369 Kelvin temperature, but above this temperature, it transforms into beta sulfur. This is very important point. The stability of alpha sulfur at 369 Kelvin temperature, but below this temperature, if temperature decreases than 369, then it can be transformed into the beta sulfur. S8 molecules of sulfur, S8 molecules of sulfur having puckered ring structure. What about the puckered ring structure? Puckered ring structure is what? Boat-like structure. Boat-like structure can possess by the S8 molecules of the rhombic sulfur. It has the puckered ring structure. It is prepared. The rhombic sulfur is prepared. How to prepare the rhombic sulfur? Rhombic sulfur is prepared by evaporation of roll sulfur in CS2, carbon disulfide. So all these points are concentrated to the rhombic sulfur. If rhombic sulfur is asked for the 2 marks, then write all these points. First, it is also called as alpha sulfur. Rhombic sulfur is also called as alpha sulfur. It has pale yellow in color, and it has the orthorhombic crystal shape. It has melting point 385 Kelvin temperature, and density is 2.06 grams per centimeter cube. That is density. It is insoluble water, cannot soluble in water, but soluble in carbon disulfide, organic solvent. It becomes stable below 369 Kelvin temperature. If temperature is below than that of the 369, then it becomes stable. But whenever the temperature is increases, then it transforms into the beta sulfur. The S8 molecules of sulfur having puckered ring structures. It can show the puckered ring structure like by that. This first sulfur, then second sulfur, third, fourth, and this is fifth. Then sixth, seventh, and eighth. This is the puckered ring structure. Boat-like structure can obtain whenever the S8 atoms attach with each other by single bonds. That is the puckered ring structure of rhombic sulfur. Then second allotropous of the sulfur is the monoclinic sulfur. It is also called as monoclinic sulfur is also called as beta sulfur. Monoclinic sulfur is also called as beta sulfur, like to the rhombic. Rhombic is called as alpha and monoclinic is called as beta sulfur. It is bright yellow in color, bright yellow in color and solid. Bright yellow in color and solid, having the needle shaped crystal structure. See again, monoclinic sulfur is also called as beta sulfur. It having the bright yellow in color, solid in nature, and needle shaped crystal structures of the monoclinic sulfur. It is soluble in CS2. It is also soluble in carbon disulfide. Then it has melting point of monoclinic sulfur. How to melt monoclinic sulfur? It has melting point 393 Kelvin temperature. Whenever the temperature is given 393 Kelvin, then it becomes melted, having the density 1.9. The density of monoclinic sulfur is 1.98 gram per centimeter cube. That is the density of monoclinic sulfur. Monoclinic sulfur is stable above 369 Kelvin temperature. Monoclinic sulfur is stable above 369 Kelvin temperature, but below this temperature, it transforms into alpha sulfur. So this is important point. The monoclinic sulfur is stable above 369 Kelvin temperature. More than 369 Kelvin temperature it becomes stable. But below this temperature, if temperature decreases below this temperature, it transforms into the alpha sulfur. Beta is converted into the alpha sulfur. It also possesses S8 molecules Lec-8 molecules also possess puckered ring structure. Monoclinic sulfurs containing acid molecules and also possess the puckered or boat-like structure. It is prepared from rhombic sulfur. Monoclinic sulfur is prepared from the rhombic sulfur when it is melted and cooling. Okay, so the question asks for 3 marks allotropy of sulfur, then write rhombic and monoclinic both for 3 marks. But independently, question can ask for 2 marks. Explain rhombic sulfur for 2 marks, then write only these points of the rhombic sulfur. And again, monoclinic sulfur can ask for 2 marks, then write the monoclinic sulfurs. The distinguish of rhombic and monoclinic, it is alpha, this is beta. Has the pale yellow in color, bright yellow in color. It has orthorhombic crystal, it is the needle shaped crystal. Likewise that it has a melting point 385, it has 393 Kelvin temperature, its stability below 369, then its stability above 369 Kelvin temperature. So all these points are included for the allotropy of sulfur. Okay. So in this class we discussed about first oxyacids of sulfur and then allotropy of sulfur. Okay. Thank you.